In this video, we're going to talk about the differences and similarities of theoretical and experimental probability. Now, these words might be a little daunting because they seem kind of long and maybe we don't know what they mean. So let's start by defining these two. Theoretical is, in this case, like a hypothesis. It's what we think is going to happen, right? In science class, when you talk about hypothesis, we mean something that can be tested, right? It's what we think will happen. It isn't what has happened, because a hypothesis is what you think is going to happen, right? Nothing has happened yet, but you can test it. Whereas experimental probability is the actual test, right? In science class, when we talk about experimental, it's something we're actually testing, right? It's like the test actually happened, right? So it's the difference between predicting the outcome of flipping a coin, right? So if we have a coin, its outcomes are heads or tails, right? Those are the only two outcomes. Now, if we were to guess the likelihood or the chance of getting heads, well, we know that that's one outcome out of two. This would be a theoretical probability because we haven't flipped it yet. We're just guessing what's going to happen. Whereas if we were to flip the coin 10 times and get 4 of them heads, that would be experimental, right? So if I flipped the coin 10 times and 4 of them were heads, that would give me a probability of 4 out of 10, which is different from the 1/2 theory or hypothesis that we had. So that would be like experimental. So let's look at some definitions. So we have theoretical probability. By definition, it's the expected, right? We're seeing that word again, expected probability of an event occurring, okay? This is what we're used to. This is what we've been doing so far. How many desired outcomes out of all total outcomes, right? So going back to the coin thing. Let's check out experimental. Experimental probability is found using the frequencies from an experiment or game, right? It's back to that coin example I said earlier. If you get heads 4 times out of 10 flips, well, that's 4 out of 10. That's different from the 5 out of 10 that maybe we were expecting, because we know that 5 out of 10 is 50%. So let's look at a couple examples. In this experimental example, right, so now we're looking at experimental, they tell us here that this is going to be experimental, okay? It's a test, we're doing something. 2 number cubes, okay, when they say number cubes, they just mean dice, are rolled 75 times. So the number of trials or experiments was 75. So we have a total of 75 trials that happened. And we rolled a sum of 9 10 times. So that happened 10 times. We want to know, what is the experimental probability of rolling a sum of 9? Well, we can just look at the number of desired outcomes, desired or wanted, out of the total number of trials, right? Or how many times we rolled the dice. So we know that that's 10 out of 75. If we simplify that, if I take out 5 from the top and bottom, we get 2 out of 15. Okay, but let's think about how this would look if we were finding the theoretical probability. Well, I know that I could set up a probability table to find that sum of rolling 2 dice. I know that any die, my faces are going to be 1 through 6. And I can just find all the ones that have a sum of 9. Well, I know that 4 plus 5 is 9 and 6 plus 3 is 9. So anywhere I've got 4 and 5, so there's one. 4 and 5, that's another. And then anywhere I have 6 and 3. So that's 4 of the desired outcomes. And if I wanted to find the total number of outcomes, since we're looking at theoretical, that's going to just be all of the outcomes in this table. Well, I've got 6 here and 6 there. We know to find the total number of outcomes, it's those multiplied together. It's 36. Well, 4 out of 36, I can divide both by 4. Gives me 1 out of 9. So I have 2 different outcomes here. I have 2/15 here and 1/9 here, 2 very different fractions, right? This is our experimental. It was the result of our test. And here was our theoretical. This is what we would have expected to have happen had we made a guess before rolling the dice. Let's look at another one. On the left, it says a coin was tossed 30 times. Right away, you should think, well, this has to be experimental. Okay, something actually happened. Heads occurred 12 times and tails occurred 18 times. It says find the experimental, there it is, experimental probability of tossing tails. So we are looking at the number of times that tails occurred. Okay, so tails occurred 18 times. And we know that the total number of times that it was tossed was 30 times. So the number of trials was 30. So in this case, our experimental probability of tails is going to be that 18 out of 30. And I can simplify this by dividing out 6. And I'm going to get 3 out of 5. So how does that compare to our theoretical probability, right? So on the right, it says compare the experimental probability found on the, that should say left, with the theoretical probability of tossing tails. Well, we know that if we toss a coin, our only outcomes are heads or tails. Well, that's 2 outcomes here. And only one of those outcomes is tails. So the theoretical probability is going to be 1 out of 2, 1/2. Okay, so how does that compare to what we have here? Well, how can we compare 2 fractions with different denominators? We can do that by finding like denominators. Well, I know that 5 and 2, if I multiply them together, I get 10. So I could change both to a denominator of 10. So I've got 3 out of 5 is the same as 6 out of 10. Whereas if I change this one, it's going to be 5 out of 10. Well, 6 out of 10 is greater than 5 out of 10, but is it significantly greater? Is it a lot greater? Is it enough to make you think that maybe there's something wrong with those coins? Probably not. We know that if I were to continue flipping that coin, it would tend to become more and more like 5 out of 10 probability, or 50%. So 6 out of 10 is not significantly large enough to make us think that those coins are maybe loaded coins. All right, now it's your turn. I want you at home to flip a coin 20 times and record how many times you get heads. And in the Google Classroom, for the question for this video, I want you to tell me, how does your experimental probability of getting heads compare to your theoretical probability for getting heads? Remember, experimental is how you test it. Theoretical is your hypothesis or what you expected to have happen. Can't wait to see your responses.